So I think the recording has got started. So I'll share the screen. So we got the Oracle SQL developer on the screen. So today what we're gonna discuss is we're gonna discuss about the Windows function. Okay. So to understand about the Windows function, let me have a sample table. We'll drop if there is an already table. If already we got a table in that same name. So I'm just going to create an employees table. So already I got a table, so I'm just dropping it. So let me create with a new structure. So employees table here. So let me create this. I'll select this, go for this play button. So let me see if this table is created. You can able to see from here that table employees is created. But let me use the describe command to see whether the table has been created properly or not. Okay, we have created, we got the 4 columns along with the data types here. Okay, so let me insert some sample rows of data. So I got 4 rows of data inserted here. Let me select it. Let me run it. Since these insert is all a DML command, DML commands has to be committed from our side. So let me commit it as well. So commit is complete. Okay. So we are good. So let me see whether I got all the rows. I got all the rows inserted. I'll put select star from employees. I'll check. Yeah, I got. So basically understanding about the data, how many rows are there? We got 4 rows. What does each row represent? Each row is representing one employee. So if I wanted to know what is the total salary paid by the company, I can able to add this manually, right? 5,000 plus 7,000 plus 4,000 plus 6,000. I think almost we get 22,000, right? So if you wanted to do this using query, how you do this? You put select sum of salary from employees. So this gives you 22,000. Okay. But how many employee rows existed there? We got 4 rows, right? But how many rows did this sum is giving up for us? It is giving 1 row, right? So the important observation is, see, after the query, I'm getting only 1 row. Okay. So I don't have any detailed rows. I don't have the details like John is disappeared, Smith has disappeared, David, Mary or disappeared. When I make sum of salary, I get only one value. I don't have the details of the employee like David, John, Mary, and Smith. I don't have them. See, why? Because aggregate functions will combine the rows, right? See, basically, what is happening here is it is converting these multiple rows, it is summarizing to a one row, right? Understood? It is summarizing many rows becomes 1 row, right? Eventually, this happens even when you do a count also, right? So count is also one other aggregate function. So when I put select count of star from employees, I'm getting 4 again, right? Again, 4 rows became 1 row of data. So basically, what is the understanding we got here is the aggregate functions will summarize the data. So all the aggregate functions, sum, average, count, minimum, max, all these will summarize the data. That means these functions will take many rows and produce fewer rows, sometimes only 1 row. Okay. Suppose your manager is asking you, "Hey, show all the employee name salary." Okay. Along with that, I need the company total altogether. For example, what I'm trying to explain is, so we got employee ID, employee name, department, and salary, right? So what is the expectation is, hey, show me employee name, salary, and total. So for each row, I need the total. Like 22,000 is the total, right? I need 22,000 in after this 5,000, and 22,000 after this 7,000, 22,000 after this 4,000, 6,000 after this, 22,000 after this 6,000. So what is the expectation that he is having is you want a table something like this. Okay. So can a simple sum of salary can do that. For example, if I put sum of salary, will this do that? No, because it will return only one row. Because employee rows will this employee column and salary column will get disappeared, right? So we'll get only one output. If I put this sum of salary, I'll get only 22,000. I can't able to take this expected output. But my expectation is I need both employee details and as well as the company total. So this is why Windows function exists. This is one of the use case I'm telling. Okay, there are many other use cases. One of the use cases that I'm telling that this is why Windows function is existing. Okay, aggregate function is giving one result. Okay, but Windows function I can able to have the details of the employees. Along with that, I can able to have the company's total income that is paid to the employees. Understood? See, uh, this output can be taken from subquery also. Okay, using a select class subquery, we can able to take this output. Okay, but here the question arises: why can't I make subqueries? Why I need this Windows function to do this? See, the reason is I'm telling you. See, let me put the select star from employees. See, in the select star from employees, right? If I wanted to make this output, the above expected output, this output, okay, using subquery, how could I make us select employee name, salary, and I have a select subquery. Okay, see what is subquery? Select query within another query is called a subquery, right? See here, I'm just making select employee name will be the first column, salary will be the second column, and third column I will have something called the sum of the salary, right? So if I run this, I'm getting the expected output, whatever that I expected, right? The same output I'm getting. Like I'm getting the total salary that is paid by the company to all the employees for each row. So I'm preserving the employee details along with the total salary, right? So why Windows function is, see at this point of time, right? I can say, see Windows function, uh, before Windows function, right? Many developers worked for years. So subquery has been fine for them. Okay. But subqueries for some complex problems, right? It will be more complicated to understand because some problems will become ugly, complex, and slow using subqueries. Understood? Huh? For example, I'll tell you. For example, if your manager wants to rank the employees based on the uh, salary. Okay. For example, if I wanted to rank this, Smith is going to be number one rank because he is getting the highest salary. Mary is going to get the second rank. John is the third rank and David is the fourth rank based on the salary if I'm ranking it, right? So to get a table output something like this, employee name, salary and rank. So if I do with subqueries, right? Yeah, I'll just put an example. How the subquery will look like is something like this. See, the subquery is actually a correlated subquery. So we are using a correlated subquery with as a subquery inside the select class. And I'm using plus one. So this is something which is little complicated for beginners to understand, right? So see, if I put this, I'm getting an output here. Okay, I'm getting an output here. But is this easy to understand? No. So even if I wanted another requirement, for example, I wanted to show the previous employee's salary. Okay, so something like this. I'll put it here. If my requirement is something like this, like I need John's previous salary is going to be David's salary, Mary's previous salary. Likewise, if I wanted to take the previous salary, so without Windows function, it's going to be a very complex join logic is going to be. It is not going to be easy. Okay. See, rather than having like this, we can able to have some questions like the employee's current year's salary and comparing with previous year's salary and all. If you wanted to do that, right, that will be very difficult. It is possible, but though it is will be not as easy as that we use in Windows function. Understood? For example, if I wanted to make a running total, so running total, see, running total is nothing about the cumulative addition. Like, see, this is 4,000 or 4,000. When it comes here, right? So this 5,000 plus 4,000 is going to be the 9,000. So when I come here, the 6,000 plus 9,000. Understood? Huh? So David's running total will be added with the salary of John, and that will be the running total of John. Similarly, Mary's salary is added with the running total of John, and that will be the Mary's running total. Similarly, Smith's salary will be added with the running total of Mary, and that will. So the immediate previous rows running total will be added with the salary of the current row. That is called as a cumulative addition or a running total. Even you have learned this running total in your Excel as well. If I wanted to perform the same thing in using subqueries, right? That's going to be something like this, okay, which is going to be a little complicated for the people to understand, right? Because it's already becoming difficult, right? See, our table has 4 rows of data, so it's very easy. Now imagine we got 10 millions of rows with 50 columns and 20 different calculations. Subquery becomes huge, right? But Windows function will make it easy. Windows function will make it easy. Understood? See, for example, I gave a query here, right? So this is the query that I given for you, right? The same kind of query, okay? I can able to take it with a very legible and simple block of code using Windows function. See, this is going to be the Windows function. One of the Windows function called rank. See, just a one line of code, right? Rank over order by salary descending. If I do this right, that is also going to give me the same output. See, this is also giving the same output, and this is also giving the same output. Understood? But which is more simpler? Windows function is simpler, right? The first thing is the real reason why we use this Windows function is Windows functions makes the SQL easier to write for us, right? And Windows function are easier to read. Suppose a new developer comes, which query seems easy for him? This query will be easy, right? Windows function will be easy, right? And even you understand that the Oracle optimizer has some special algorithms for analytical functions. Oracle engineers specifically optimized these Windows functions. See, these are the Windows functions: row number, rank, dense rank, lead, lag, sum of over, count of over, like that. All the aggregate functions with the over for these and all. The Oracle engineers are specifically optimized. So these often will perform better than multiple correlated subqueries. I'm saying that notice that I'm saying that it often perform better than the multiple correlated subquery. I'm not telling that always. Okay, just note that point as well. See, some calculations are almost impossible to write elegantly without Windows function. Okay. See, for example, if I wanted the previous salary for a case like this, okay, I have a dedicated Windows function called lag, lead, and all. Suppose if I wanted the running total, I have a dedicated Windows function called sum over, sum of over. Suppose I wanted a ranking like this, I have a dedicated Windows function called, you see, I got rank over. Understood? If I wanted to know about the top 3 employees per department, I can able to use this row number. See, all these things will do it practically. But as of now, what is our intention is to understand why we wanted to learn the Windows functions. See, Windows functions were not created because subqueries cannot solve the problem. They were created because SQL becomes shorter, easier to understand, and Oracle can optimize these operations better. Ranking, running totals, previous row, next row calculations can become much more easier using the Windows function. See, in a one-line understanding, Windows functions are the special functions. Okay, these analytical functions are special functions that can perform the calculations across a set of rows. Okay, while keeping each row visible for us. Okay, each row is visible for us, right? Okay, and we are avoiding many complex joins or subqueries. Very simply, we can take it over. Understood, right? So let's get one step ahead. Okay, so I'll just clean the book. Okay, so see, what if I wanted the total salary? So what I'll do, I'll calculate the total salary using sum of salaries, right? So this gives me the total salary, right? So I made 4 rows an input, but output is 1 row. Okay. See, if I wanted, if I wanted something like I need all the employees detail along with the detail row, I can able to use something called sum of salary over the empty parenthesis. And this will give me the expected output. So did Oracle calculated the total salary in this output table? Yes. Did employee details are disappearing here? No. See, when I did select sum of salary from employees, it's disappearing. The employee details like Smith, those people have went somewhere. But when I make this sum of salary over, right? So the details of the employee is still being preserved here, right? So without an over, without an over, we get only one row. With over, we can able to get 4 rows of data. Only one thing changed here. We added a over. The comparison between the this query and the above query, right? This query and above query is nothing about this over. Understood? So over tells the Oracle to treat the function as a Windows function. See, Windows function can also called as analytical function. Okay, instead of considering it as a normal aggregate function, consider it as a analytical function. Okay, understood? See, when Oracle sees the sum of salary over, Oracle will think, hey, this is a Windows function. Keep the rows, perform the calculation, return the result for every row. Understood, guys? Any doubts? No, right? So similarly, you can able to do the average. For example, if you wanted to make the average of salary, 1 minute, average of salary. So I can able to make it with the over. Let me make it with the over. Good. Similarly, I can able to make the count. So when I make the count, just count is going to be give me a 1 row. I can able to make it with the over. See, I got it. See, what does this empty over? This empty over means, because there may be a question why you keep this parenthesis empty. See, when I make the over with an empty parenthesis, empty brackets, I'm telling use all the rows in the result set as the window. Okay, so Oracle will see this. For example, let me take a sum of salary over. Okay, so how Oracle will think for this is it will take internally. How Oracle will think about this particular sum of salary over is it will take all the rows, calculate the total salary, and show result on every row. Understood? So we can able to visualize something like with the name, we can able to visualize the windows. How the things will work is it will visualize it. How it will visualize it is first it will see the table and it will look the entire table and it will take the window. So it will find the total for it and it will put the result on every row here. Understood? So some people may ask you, what is this over? Is it a function or what? No, over is not a function. Okay. Over is a class. Okay. Just like where class, group by, order by, having, over is also a SQL class. Okay. See, can we write only over? This is also sometimes people will come up with a question. Can I put something like select over from employees? No, this is not a valid syntax. You have to use sum of salary over, average of salary over, count of salary over, something like this. Understood? So over means use all the rows in the result set as a window. Okay. See, you can able to do minimum of salary and maximum of salary with over also. Okay. So what is the ultimate summary that we have learned right now is, so we can do all these things: sum of salary, average of salary, count of star, minimum of salary, maximum of salary. Okay. So I think everyone is comfortable with this. Over. I think you have already known about this sum, average, count, minimum, these aggregate functions. Now we added the over to understand about the Windows analytical functions. Good. Okay. So now let's just focus on the syntax. See, sometimes people will use inside the over, they will use partition by. Okay. They will use partition by. Okay. So I'll just come to that point. Before that, I'll make my table ready. I'll just insert some new data into the table called employees. So it truncated the table. I'll show the table. Okay, I'll show the table how going to look like. So I'll put select star from employees to show you all what the how the table looks like. See, this is the table that I got. John IT, Smith IT, David Achar, Mary Achar, John James Sales, and Peter Sales. Okay, we got some 6 rows of data, right? See, focus here clearly. We got 101, 102, 103, 104, 105, 106, 6 rows of data with an employee IDs of 101, 102, 103 until 106. So still now we have understood the aggregate functions with over is going to give us the Windows analytical function. Okay. See, there is something called partition by which we are going to about to discuss now. See, let me do a over without a partition by, and I'll show you the difference. I got the employee name, department, salary, and sum of salary over, just over. Okay, this is just think about it is an alias. Okay, I'll put an as here. It is an alias. So if I put this, what I'll get? I'll get the total salary. Understood this? So how did Oracle calculate this? Oracle calculated the addition of all these values in this particular column salary, and it used that total for each row. For the entire result set, it has made for each row because of over. But suppose your manager is saying it don't give company total salary, please give department total salary. See, this is the company total salary when I add everything, right? But I need department's total salary. For example, for this IT employees, right? The total salary is 7,000 plus 5,000 is 12,000. I need that. For HR, I need 10,000 as a total salary. For sales, I need 5,000 plus 3,000, 8,000 as a total salary. So what is the expectation is they're expecting the output something like this. So the addition of this two, these two things, right? That is going to be 5,000 plus 7,000, 12,000. So similarly for this department HR, 6,000 plus 4,000 is 10,000. Similarly for the sales, 3,000 plus 5,000 is 8,000. So they are expecting something like this. If your manager is expecting something like this, right? At this point of time, right? So at this point of time, we need something called partition by. Okay. So I need this output. Okay. So I'll just put it at the bottom. Okay. So see what the change I'm going to make here is inside this override, I can able to write something called partition by partition by what? Partition by department, right? Partition by department. I'll make this as a department total instead of total salary. Department total. I'll make the alias name something more logical and meaningful. Now, if I put something like this and if I run this, looking at this, could you able to understand what we got is we got the department wise total. What did partition by did here is one of the most important understanding here, guys. Oracle will internally behave like it will take this HR, add this 6,000 and 4,000 and give it as an output for those two rows. Okay. Similarly, we have to add this 5,000 and 7,000 for IT and we have to put it as a value for this two rows. Similarly, for sales, I have to add this 5,000 and 3,000 and add it as a total department total for that particular two department employees. Understood? So without partition, the window is a complete salary column, but with the partition, it's going to be under HR separately a window, under IT a separate window, under sales a separate window. Three separate windows. So partition by divides a row into some logical groups before the analytical function is performed. Repeat, partition by divides the rows. See, it's dividing the rows. This is one set, two set, three set. Divides the rows into logical rows before the analytical function is performed. See, people will always confuse the group by with this partition by. I'll make a difference between group by and partition by. See, group by, see, if I do a group by, look at here, if I do a group by here, right? What happens here is, I'm just getting only three rows. Employees detail is still, employees details is still disappeared here, right? But when I make a partition by, you see, employee details is also preserved. Does partition by reduce the rows? No, does not reduce the rows. The rows remains the same. The six rows we got, six rows we got in the output. But group by will reduce the row. The rows are collapsed in group by. Are we good with this? I'll take another example for you again. If I wanted to count the employees in each department, how many employees we got in each department, guys? We got two employees in each department, right? If we wanted to perform, right? How can I do that? See, I alter in the same query itself. Okay, I'm removing the salary. Here, I'm just going to make the count. And I'll take all the rows, also all the columns, count of star over partition by department. So if I give this right, what I'll get the department count for each row. Okay. For each department, it will take a count and it will put that count in those department employees' respective rows. Understood? So uh, why is IT showing 2 here? Because IT has got John and Smith, so only 2. Why HR is showing 2 here? Because HR has got 2 employees, David and Mary. Likewise, sales has got Peter and James, only 2. Understood with this? Any doubts? So we can also do the same thing with the average of salary as well. We did for count, we did for sum. We can do for the average also. Average salary for that particular department, like average salary per department. Are we good? So basically, as of now, we understood what is over. Over will use all the resultant rows as a window. What is partition by is it will split the rows by the department. What I'm giving here, right? It split the rows based on that particular column that you're mentioning there. As of now, I mentioned department DEPT. So it split the rows based on by the department, and it will calculate separately, but it will make sure that all rows are visible for you. Okay. I hope we are good till now. Over is one big window. Partition will divide the windows into smaller windows. Right? Okay. So we'll just move forward one step ahead. Okay. So until now, we have learned over. We have learned over with partition by. Okay. So both calculate on group of rows. Now I'm going to introduce something called order by inside the over. See, inside the over, we got partition by, right? Likewise, we can also have something called order by inside this over. See, generally we have learned about order by, right? What is the order by? It is for sorting, right? Sorting. See, if I put a order by salary, based on the salary, it will make a sorting here. So 3,000 is the minimum salary that comes first, then second 4,000, then 5,000, then 5,000, then 6,000, then 7,000. It has made something in the ascending order. If I wanted to make it as a descending order, I'll put DESC here, so it will make it as a descending order. These are all that we have learned earlier. Okay, but now let's see how this is going to work within a over in a Windows function. How order by is going to work. What I'm going to tell you is I'm going to make you explain this one. So sum of salary over order by salary. Okay. So is the same order by that we have learned before? No. See, even though this order by, okay, I'll put this. Okay. So this above one and this below one, this one and this one, we have order by. Here also we got an order by. Here also we got an order by. Is this is this the same order by? No. They look similar, but they serve different purposes, guys. Please make a note of it. These two order bys are serving different purposes here. Okay. So what I'm going to do is just make sure that I'm having the table uh, according to my data. So let me again truncate the table and let me insert the data that is preferable for me. So I'll just insert it. Don't worry, I'll just show you the table how it looks like. Got it. So we got 101, 102, 103, 104, four rows of data with John, Smith, David, and Mary. Okay. So if I do a normal order by, okay, by salary. So what I'll get as an output, first row will be the David who is as a minimum salary, and then John, and then Mary, and then Smith comes last because he has having the highest salary. Understood? So what did order by do here? It sorted the output. Nothing more than that. No calculation, no windows, just a sorting, right? Let's come to the same thing we can do with the sum of salary over without an order by. Okay, let's do first without the order by. Already we did this lot of time. Let me do it again for you. So we got the totals here. Okay, now let me add the order by salary inside this over now. See, I'll put order by salary inside this over. Now what this going to give me is when I put inside the over, I'll run this for you. What I got the running total. This is not total cell. This is going to be the running total or cumulative addition or cumulative total, right? So what is the understanding here is why did the 22,000 becomes 4,000, 9,000, 15,000, 22,000 is Oracle, what it will do internally is, see, because of this particular, I'm highlighting thing. See, focus on the screen. I'm highlighting over order by salary, right? Because of this particular part of query, Oracle will first arrange the rows. Okay, what it will do is, what it will internally do is, first it will internally arrange this rows by salary. First, first step. Then for the current row, Oracle looks from beginning up to the current row. So from the beginning up to the current row, what I have only 4,000, right? So it will put 4,000 here. Then it will go to the second row. So second row is the current row now. So here it will look from the beginning up to the current row. Beginning up is what, 4,000. The current row is 5,000. So it will adds up and it will give you what, 9,000 here. Understood? Then it will go to the third row. Third row becomes a current row. So what I said, it will it will look from the beginning up to the current row. From the beginning up means it will add 4,000 plus 5,000 plus 6,000. It's going to be 15,000. Similarly, when it comes to the last row as a current row, it will add right from the beginning up to the bottom current row. So we'll get something called 52,000 here. Are we good? Right? So basically, this is called as cumulative sum or running total. Okay. See, the important understanding here is order by inside the over will tell the Oracle to process rows in a sequence. So Oracle now knows this is the first row, this is the second row, this is the third row, this is the fourth row. So it will process the rows in a sequence. It can perform the running calculations, right? When I don't put this order by, it's just giving the total salary, right? I'm sorry, I'm not put the running total now. I'll have to put something called just total. So 1 minute. Total. But when I put order by, that becomes running total, right? The same thing we can able to make it with the uh, count, right? So count of star over order by salary. This gives a count. Okay. So for the first row, it will take a count and it will add, right? So basically for the first row, so let me make the select star from employees. So let's take it this way. Okay. So I'll just remove this. So if I make the count of star over order by salary, right, what happens? It will go to the first row. Okay. For the first row, what is the count that we got is 1. Then it will go to the second row as a current row. So it will look from the top to the current row, right? So David and John, it becomes 2. So for Mary, it becomes 3. For Smith, it becomes 4, right? So some of the interview questions that may be asked in interviewers, like, does the order by inside the over simply sort the rows? No. The order by inside the over will not just simply sort the rows. Normal order by will sort the output, but order by inside the over is going to define the sequence for calculation. The purpose is to define the sequence for calculation. Okay. So we have understood about over first and over with partition by and over with order by right now. Okay. So I'll just make a summary here. So what you have understood is what is over is, this is one window, this is multiple windows, this is a sequence inside the window, right? So we can able to have, see, try to practice after this, plus try to practice all these things. Sum of over, count of over, average of over. Okay. Are we good? Just give me 1 minute. Okay. So the next thing that we're gonna do is, the next thing is about the row number, rank, dense rank, lag, lead, those kinds of index functions we have to go forward. So we'll do those things later. Okay. By the next session. So as of now, uh, try to understand this. See, if you people have doubts, or if people wanted to have a separate SQL course or Python course or machine learning course, feel free to catch up me. So I'll just leave my mobile number in the description of this video. So you can able to connect me if you need any kind of personal customized classes for you. Okay. Thank you, everyone.